We've been practicing the fundamental theorem of calculus to find the area under a straight line, which gives us the ability to compare our calculus results with our geometric intuition. And what we're going to do is we're going to look at a third example in this video. So this one's a little bit different yet. We are taking the integral of the same line from -1 to +4. So you see that here is -1 and here is +4. And so it traces out, instead of a single trapezoid, it traces out these two triangles. And over here, I calculated the area of the two triangles. And so the triangle on the left has an area of 6.25, and so does the triangle on the right. So as we calculate the definite integral, I want you to pause the video for just a half a second and come up with some intuition of what you think this integral is going to calculate out to be. And so we'll see if you're right or not. So once again, this function has the same antiderivative that it has up to this point. It's going to be -x squared plus 3x. And we're going to evaluate that from -1 to +4. So that means we give ourselves a little bit of space here. We evaluated at 4 and we evaluated at -1. It's a little bit backwards, I guess, that we're talking about the integral from -1 to 4, but then we calculate 4 and -1 in the opposite order. But get a helmet. All right, and -1 squared plus 3 times -1. All right, so -4 squared, remember, we've got to be careful with the order of operations and what that negative sign and the squaring mean. Minus -1, and then +3 minus 1 gives us a product of -3. -16 plus 12 is -4, minus -1 minus 3 is also -4. So we have -4 plus 4, which gives us an integral of 0. All right, was that the guess you came up with as what the definite integral would be? And whether it is or not, can you see why this would be the case? Why this integral, we might expect it to come out to be 0? Well, remember what we said in the last video, that areas that are above the x-axis we're going to count as positive areas, and areas that are below the x-axis we're going to count as negative areas. And since these two triangles have the same area, we're going to cancel them out when we add them together. And so that gives us a balanced definite integral of 0 in this case. Okay? There are two more examples down here. I want you to take a stab at solving them, give you a little bit of practice at evaluating definite integrals. And in the next video, maybe what I'll do is I'll take a second and I'll show you how you can calculate these integrals using your graphing calculator, because that is one of the tools that will be available to you when you take the actual AP exam.